Hello everyone. Good morning all. Good morning Timothy. Good morning Mohammed, Alex, Mina, Benjamin, Jacqueline, Nicole, Salma. Thank you for being here. We are starting with our test number 3 material. Oops. I'm sorry, I just noticed that I was on mute. I was mute. Now I am on mute. Can you hear me well? Is everyone perfect? Okay. So good morning everyone. Thank you for being here. Today we are starting test 3 material. Okay. I have a few announcements regarding your final the draft of the final project. I have seen in general the content of the class it is presented on the the draft that I have graded and reviewed. Okay. I would like to see a little more organization so I can follow better your explanations. Also, there are examples that are like incomplete, and there are examples that they need a little more of explanation. But that's okay. That's why we are doing a draft before the final submission. Okay, so as I told you, I'm going to give you all the credit for submitting the draft on time and following the format stated on the syllabus. Okay, although I'm going to be a little bit severe with using the rubric and the marks that I'm doing on your project, because I want to get the better of I want to get the most of from you in the final project. Okay, so don't get discouraged if you see a lot of mark or a lot of feedbacks. Those are good things, because those are things that you will improve for the second draft and for your final project. The most important is that at the end, when the final project is due, you have a complete project that will give you a good grade. Okay. All right. So let's start with test number 3. So today we are going to focus on function operations. We are going to focus on composite functions, one-to-one functions, and inverse functions. Okay, so we are going to learn how to do functions operation, specifically composite functions. Then we are going to learn what is a one-to-one function, and by the end of the class, we are going to learn about the process or the method to find inverse functions. Okay, inverse functions are going to be very important for the next 2 lectures. Next 2 lectures are exponential functions. Next 2 lectures topics are exponential functions, logarithmic functions. We are going to use those 2 functions or those two algebraic concepts to work with exponential and logarithmic equations. That's the goal of test number 3, to know how to solve exponential and logarithmic equations. Okay? No, we are not going to touch that on our lectures. Now we are going to focus on exponential and logarithmic equations. If you want to explore more on that, we can talk after class about that. Okay. Okay. So yeah, that's what we are going to do. Pay attention to inverse functions. You need to understand what an inverse function is, okay? Because it will be useful for the next 2 lectures. We are going to start with composite functions. And what is the meaning of this notation here? Okay, so we have some functions f and g, all right, and we are creating a new function based on those 2 functions of f and g, and this is the notation. Okay, Timothy, we can talk about that after class. Yeah. Okay. All right. So this is the notation for the operation of composite functions, where we're going to use two functions to create one composite function. Okay, the order here is important. How we write from left to right the first function and the second function, and this circle here, it means the composition. Okay, it is referred to the composition of those two functions. All right. When we have this order, and this is the definition of composite functions, when we have this order, the second function becomes the input of the first function, f. So g becomes the input of the function f. Let's see this in an example so we can see how we work with this. Okay, so we need to create this composite function based on f and g. All right. So we have the definition for f, which is x squared, and we have the definition for g of x. All right. So what we know about functions, about the notation of functions. So we know that inside these parentheses we go the argument of the function or the input. Usually is x, right? Because we are working on a plane with y and x axis. Y now use in function notation as f of x. Okay, but usually this here is the argument of the function, right? And whatever is in the argument goes in all the places where in the function equation, if function equation is the right side. So for example, the function equation of f is x squared. So, and we know that x is going to be the input because x in the left side of the definition of f is in the argument. So x is the argument. So whatever x is, it will apply to the right side to the x variable. Okay. So the argument, okay, we know the argument of the function from the left side in the definition, f of x, and then we apply the value or the expression for that argument into the function definition, which is the equation on the right side. Okay, but here, since we're creating a composite function based on f and g, now g becomes the argument of f, right? So what we are going to do, instead of putting x in the argument, now we are going to use g of x. Okay, so that's the first step. So we replace all the arguments in f with g of x, and we have the definition of g of x here. That definition is x plus 1. So we go here and we put x plus 1, and then we got the composite function of f composite g of x. Okay, the order is important. G is on the second place here from left to right, so that means that g becomes the argument of f. Let's see the other way. So now we have g composite f, or composition of f of x. Okay, so now f becomes the argument of g. So remember, here is the argument. So we go and put f of x here. We go and put f of x here. Okay. F of x is x squared, and then we finish with our composition of function, g composition of f. Any question on this? Let's do our first example. Okay, so the example number 1 is giving us the function f and the function g. Okay, and the first composite function that we are going to create is f composition of g of x. Okay, so we are going to start with the definition. The definition says that this is going to be g of x is going to be in the argument of f. The definition of f is 2x squared minus 3. So 2, now x is replaced with g of x. Okay? Then we use the definition of g. So 4x all the square minus 3. Okay, let's finish this exercise with expanding everything here. So we need to follow the order of operation. Power, the exponent goes first, so we have 2 times 16x squared minus 3. Okay, and this is equals to, I think I put it here, to 32x squared minus 3. Okay, let's do the other one. So g okay, yeah, let's go back. Which one? Which step? Let's see. One. Okay, so what I did there, we have an exponent. Okay, and inside the exponent, that exponent will apply to 4, but also will apply to x. So 4 raised to the power of 2 is 16, right? And then x raised to the power of 2 is x squared. Since we don't have a value for x, so we just write the expression x squared. Okay. Okay, so let's do this one. So we have g of, the definition of g is just 4x. So in that place we are going to put f of x, and f of x equal to x squared minus 3. So we have 4 times 2x squared minus 3. And then we apply the distributive property. So 4 times 2x squared is 8x squared minus 3, which is minus 12, because we have 4 times 3, which is 12. Any question? Okay. So let me grab our definitions here because we are going to use them. So we know that f of composition of g is 32x squared minus 3, and we know that g composition of f is 8x squared minus 12. Okay, now what we have here is an actual value for x. So what we are going to do is just evaluating. We are going to be doing an evaluation for each function. So f composition of g when the value of x is 1 is, what we are going to do is to take this 32, and then we are going to replace x with 1 minus 3. So this is 32 minus 3, and that is going to give up to 29. Okay, we have the definition for g composition of f of x. So we have 8. We replace x with 1. So this is 8 minus 12. This is equal to -4. Okay. We can get creative with compositions. Yeah. Yeah, that's a good question. Let's see. Okay, so we have the power here, right? And this power will apply to anything that is within this parenthesis. Okay. Good question. Okay. Now, this, I don't know if this is confusing for you or not, but we are going to create a composition with a new function with just one function, because we're going to create f composition of f. So this is, let's see. Oh. Did you try? Did you try it? The first thing that I would like to do is to create the function. Okay. And then we have f of x. I know that vocabulary gets confusing here, but that's okay. So f of x square. Okay. This is not too complicated. What you want to do is to pay attention to each step. If you follow each step correctly, you are going to be okay. Okay, so we are here. So we can expand this, or we can leave it like that. Okay, we don't need to make things more complicated for us, because the only thing that we need to do is to replace the value of x with the value that is given in the exercise. Okay, so there is our definition. This is our definition of f composition of f. Then what we need to do is to replace x with -2. So that is what we're going to do here. 2 times 2, okay? So this is going to be -2 squared minus 3. All this raised to the power of 2 minus 3. Let me keep this, let me put this to the side so we don't get confused by this. Okay, I'm gonna put it here, but remember, this is how we got the definition of f composition of f. Okay, and here is the equation. Let's focus on our actual exercise. And here you want to follow the order of operation. You want to make sure that your calculations are correct. We start with the parentheses. In the parentheses we have a power that is -2 raised to the power of 2. That gives us +4. Okay, +4. Then times 2. That is going to be 8. 8 minus 3 is 5. Okay. Check this number. Verify that you are getting it correct. Okay. The only thing I did is I solved everything inside the parentheses. Okay, next step, the power again, 5 raised to the power of 2, 25, times 2, 50, minus 3, 47. Okay. I will give you a minute to check your calculation with item number C. Let me know if you have questions. Okay, no question here? Okay. So the first thing that we want to do here is, let's move to D. So first thing that we want to do is to get this definition. And then we have 4 times, this is g of x. Let me complete this. G of x, this is equal to then 4 times g of x, but g of x is just 4 times x, so we got 16 times x. Move to the side so we don't get confused. Okay, now what are you doing here? Okay, so we have 16 times -1, so the value is -16. Okay. Any question on this one? All right, so let's move to the next slide. Okay, let's try this one. I'm going to give you 5 minutes. Please post your answers on the chat. Okay, 5 minutes. Let's try this one. Okay. Can I have your answers? Or maybe if you got, or tell me in which step you are. Mm. Okay. Then if you, okay, perfect. Let me know when you are finished one, so to review everything. Okay. Jordan, do you need more time? Okay. Uh, in which you are right now? Okay, are you working with in B? Are you working with B? Okay. Yeah. Okay, I have two answers posted on the chat. Have Jordan that is working. The rest of you, what are you doing? Are you working on the exercise? Do you have your answers? Or do you have questions? Okay. So I'm going to start and you can follow my step so to check on the step that you have so far. Okay, I see yours. Okay. So I always like to begin with the definition because that is going to guide me through the whole process. Then I now write the definition for f, but using g of x, the argument in it. Okay. Then I will replace g of x with its definition. Okay, at this point, we are good. Uh, we have done correctly the composition. Okay, But I want to go further, and then I want to expand this because I want to expand and then to combine all the like terms to simplify. So let's do that. So I have here 4x squared plus 12x plus 9. Then I have 3 times 2 is 6 plus 9 minus 1. Okay, then I think you are talking about this x, right? Okay, that x is the argument of g. That x is not part of the definition of the equation of g. Is part of the notation of g. Okay. That's okay. That's okay. It's good that happened here because those mistakes, I don't want those mistakes on the assessment. Okay, I want those mistakes here. Okay, so don't worry about that. Okay, the last thing that we need to do is to combine the like terms to simplify this. So I think I have here 18x, and then I have 9, that makes 18, minus 1, that makes 17. So this is the answer for the first one. Yeah. Let me put this back here so you can see it completely. Okay, I have Jordan, geography, I don't understand. Okay, Mohammed, we are going to do B, but I want you to make question on the step that you are getting lost, okay? So I need you to confirm each step with me. So if you can mute yourself or you can write on the chat, yes, I understand this part, I understand this part, I understand this part, so I can identify where you need the assistance. Okay, I have here, Alex, you got it right. But you, no, I make a mistake here. It's positive. Yeah, it's 17 is positive because 18 is positive. Okay, let me see if I have other answers. Timothy, I like that you wrote a trinomial, so you got the 3 terms. Your number are incorrect, but you almost got there. Let me see what else do I have. Okay, Nicole, thank you. Perfect. Okay, so let's, are we good to do item B? Any question with item A? Yes, Alex, you got it right. I got it wrong with the signs. Okay. So, Mohammed, I would like you to tell me exactly where you need, you have questions, okay? So I'm going to start with the step. My first step is to use the definition of compositional functions, composite functions. G, composition of f of x, means that we are going to take f of x and we are going to use it as the argument of the function g. Okay? So let's do this a little bit more interesting, if I can. So we have f here. Okay? I don't believe I can put this nice. That's f. Okay, so I'm going to use that color for each representation of f of x. Okay, so we have g, and then in the argument we have f of x. Let me zoom out a little bit just to see the definition of g. The definition of g is 2x plus 3. Okay, so because f of x now is the argument of g, I'm going to replace x with f of x. So I'm going to start writing 2. This is the place for x in g, but I'm not going to write just x. I'm going to write f of x, because now the argument of the function is f of x, not only x. Any questions so far, Mohammed? Okay, anyone else with questions on these steps? Okay, now the definition of f of x is here. So now what I'm going to do is f of x is going to be replaced with its definition. So I can just copy and paste this. But instead, I'm going to, let me set up this. Okay. So f of x is equal to 2x squared plus 3x. Because I missed it. Thank you. It is completely. Okay, there is the definition. By that point, we are good with the function. What we want to do is to now simplify. Okay, we want to expand, we want to multiply, we want to put together all the like terms to simplify, to have a definition more, an equation in simplified terms. Okay, any questions so far? Okay, so let's do this. So we distribute 2 within all the terms, with all the terms within the parentheses. And then we combine like terms. And that is our final answer. Questions? Yeah. Let me see if I have another one that is good to try. Okay, those are examples. I will get back to this example just in a moment. Let's do these exercises here. Are they the same? No, they are different. So let's do this one. Let me copy and paste this. Okay. So we are going to do f composition of g of x. Okay, and we start with the definition. So now g of x becomes the argument. And let me use a different color for g. Let me just fill down. Okay. So next step is we're going to take the definition of f, but instead of using x, what we are going to do is to use g of x, because e of x now is the argument, square plus 1. Okay. Then what we need to do is to replace g of x with its definition, which is 2x squared plus 3, and then we complete this. Okay. And by this point, we are done with the composition. What we want then is to simplify. So let me simplify this. I'm skipping steps here, so feel free to make questions if you have. Okay, so that is f of g f composition of g of x, or f of g of x. Any other questions? Okay. So let's practice this one, because I'm going to give you an exercise that if you submit this one via email today, so you know what to do. You are going to work on this exercise, then you are going to prepare a PDF document, and you're going to submit it via email before 11:59 of today. Okay, if you got it correct, you will have 5 points. You will earn 5 points for our common test number 3. Okay, but let's practice a similar exercise so you can have a guide for that. Okay, so again, let's start with the definition. And then we got the equation of f, but then we're going to replace each x with g of x. Then we're going to replace f of g of x with the definition of g of x. And by that point, we have finished, but I want you to go further and simplify the equation. Okay, so how are we going to do this part? So we have a fraction in the denominator. To combine a fraction, even though we don't have exact value for the denominator, we can do the following. We can find the least common multiple between x minus 1 and 2. So let me go here and let's focus on that, on the denominator. The denominator is 4x minus 1 plus 2. Okay, so we have here a sum of fractions. Okay, even though 2 is an integer, we can see it as a fraction as well, because it's 2 over 1. Okay, so our goal here is to combine these two terms into one term. Okay, we are not going to get an exact value here because we have x, but we want to get an expression that represents this sum. So whenever we have, let me give you an example. When we have 3 over 5 plus, let's say 4 times divided by 6. A common denominator. We need to find a common denominator before adding this to fraction. So, yeah. I always do this to remind myself the steps, but you could do other ways if you have learned how to do this. Okay. So let me create like a face here. Alright? So the nose of this face is going to be this sign here. Okay, and then nose is a little bit up, yeah. Okay, and then the first thing that I'm going to do here, I have a happy face. This means that we are going to multiply those two denominators. Okay, so it's 5 times 6 is 30, and this goes here below. Then I will take 5. I'm going to make a happy face, but maybe a dead happy face. I don't know, with a cross here. So 5 goes to 4. So 5 times 4 is 20, and this goes here. And then we have 6 go to 3, and we have 6 times 3 is 18. Okay, and by this point we have found the a common denominator. This denominator is not going to be always the least common denominator, but it's something that is going to help you. Okay, if you cannot find a common denominator in your mind or your head or in your notes, do this and you will always get it correct. Okay, after we complete the fraction, because now we need to complete it. So what we need to do is to add these two numbers. So we have 18 plus 20. So that gives us 38 over 30. And you will notice here that we can simplify. Okay. So if we can simplify, we are going to do that. We could have simplified here before. Okay. But since I didn't simplify it at the beginning, well, we simplify at the end. So we divide this by what? What is the common factor between 38 and 30? Both are even, so we can start by dividing both by 2. So 30 divided by 2 is 30. 38 divided by 2, what is that? 38 divided by 2. Let's see. This is 1. It's 19. Okay. See, we cannot simplify further because we have two numbers that they do not share a common factor other than 1. Okay, so this is how I do sum or subtraction of fractions in my mind. Okay, but what we do here is we multiply together the two denominators, and then we carry each denominator to the other numerator. Okay, so we are going to do the same, but with this same process. If I can find where I'm writing, yeah. So let me put this here for x minus 1 plus 2. Okay, so we have a sum of fractions. And I want you to see everything. Maybe if I put this here, let me put this here, and then you put this here. then I have 4x minus 1 plus 2. Okay, so let's follow these steps with now our exercise. So this is, we done with that one. Let's focus on this one. The first thing that we are going to do is to know that each integer, each whole number is over 1. Okay, so that way we can see the entire fraction. Okay, so here we have our space. We know that the nose is going to be the plus sign, so here is the plus sign. Now we are going to take the multiplication between the two denominators. Careful, this denominator has two terms, okay? So we are going to multiply 1 times x minus 1, but that is just x minus 1, right? So this mouth is a little bit bigger, x minus 1. Then we are going to take 1 and we are going we took 1 and we are going to multiply it by 4, so we got here 4. And then let's use another color that will help us. Which one I'm not using? Purple. And then careful here, this denominator has two terms, so this is the same as 2 times x minus 1. So I think this I goes a little bit bigger as well. 2x minus 1. Okay, we need to remember that we have a fraction, and so let me now clean up this. So this is equal to 4 plus 2x minus 1, all these over x minus 1. Okay, and now what we want to do is to distribute these two. Okay, so we have 4 plus 2x minus 2, all these x minus 1, and this is, now we have like term, 4 minus 2 is 2, 2 plus 2x, all these x minus 1. Okay, perfect. Okay, so see how this, now we have a problem inside our original problem. Okay, so this is a good practice in math. Sometimes we have multiple sub problems, so we want to break those sub problems into each individual exercise, right? So what I did is, oh, I have a fraction, I have a sum of fraction, so let me focus first on that sum of fraction. Then I can go back to my original exercise. So with this sum of fraction, now that I have solved the sum of fraction, I can go here, go back to our original problem, and what I need to do is just to put 2x, x plus 2, all these over 1 minus x. I'm also going to put a parenthesis here to put in my mind, to put a structure on what I'm writing here. Okay, so now I can remember that I have that I have a fraction in the denominator. Okay. Okay, so by this point, we need to do one more thing. How do we? So what is going to be the next step? What we are going to do? Timothy, we don't have an actual value for x. Okay. So right now, yeah. Okay. Right now we have found another sub problem. We have a fraction with a denominator that's a fraction. Okay, and we need to remember the following. Let me copy this because now we have found a second subproblem here. Okay, our second subproblem here is division of fraction. Okay, but division of fraction is something very, very easy to do, to solve. Okay, let's see the example. Let's do 2, 3, 4 divided by 2/3. How do we divide this? Do you remember? Perfect. Yeah, we are going to do the reciprocal of the second fraction. Okay, the second fraction is the one that is on the denominator, so 3/2, and then we multiply. Okay. So if we change the notation here, instead of using the division operation, and we write this in a fraction, this will be 3/4 over 2/3. Let me expand this and let me move all this because you want more organization. So that is our example, right? Let me finish here and then I'm going to check yours. Okay, so this is the same as 1 divided by 2x plus 2 over 1 minus x, but we do the reciprocal times x minus 1 to x plus 2, and since we have 1, so the value will stay the same, because 1 is a factor here in this multiplication, so the product is x minus 1 over 2x plus 2. And this is the final answer. Okay, so we have solved our second subproblem here. So let's go back here and let's put our final answer. You know what? I'm going to copy and paste it because maybe I will forget. So final answer is x minus 1 over 2x plus 2. And you can recognize every time we have this kind of structure where 1 is in the numerator, we just flip the fraction that we have on the denominator, and that's the final answer. Okay, Timothy, let me see your answer. Your answer is, Timothy, I don't know. Okay, so careful. Okay, Timothy, you are creating an equation, and this is not an equation. This is an algebraic expression that we want to simplify. We don't want to solve for x. That's important because sometimes we can get confused about what is the actual objective of the exercise. That is the first thing that you want to always ask yourself. Do I need to find a value for x? Is the exercise asking me for to solve for x, or is the exercise? I think you are mixing objectives. Yeah, because if you are getting like 2 minus 2 equal to 0, that's what you. Okay. So what was your final answer? Okay. So in that let's stop there just for a moment, because you got to an actual value, and neither we have a value for x to evaluate our function, nor there is a cancellation of the variable x here. We cannot cancel x here. So that is why I'm saying that I think you are confusing the objectives of the exercises. You are maybe thinking that the way that you are working or you are presenting your final answer is it seems like you would have got a value of x at some point, or that you cancel x at some point, and that is not the case here. Yeah, but here x is just part of our equation, our algebraic expression. Okay, but we don't need to solve for x. Okay, let's do the second one. Let's do the second one. Let's do the second one. So to do the second one, what I'm going to do is to take a screenshot and open a new page. Okay. So let me work below here, and what I want is to put. Alex, is that for the second one? Okay, let's see. And then I have 4. I'm working on the definition. Let me do this way. Let me just write f of x. I don't need to write. I can just do this. Okay, let's do this. So this is g of f of x. Okay, we have the definition of g here. So this is 4 over, so where x is, now we are going to write f of x minus 1. Okay, I'm following below it, so that's my next step. Then what I'm going to do is to replace f of x with its definition. Okay, in this step we have found our first sub-problem. Our first sub-problem is that now we need to focus. Sub-problem number 1, we need to focus on 1 over x plus 2 minus 1. Okay, so let's solve this. So we can do our phase here. This phase will have a node of negative, and then we know that here is a 1. We multiply these two together, so we got x plus 1 as the denominator. Let me zoom here so you can see what I'm doing. Then I go 2 times 1, okay? Ignore the negative because we already got it here, okay? So it would be x plus 2 here, and then it would be 1 times 1, so 1 is here. Let's clean up this. So we have 1 minus, careful with this, there is a sign here and it is in front of this binomial. So let's use the parentheses to know that that negative goes to entire binomial, okay? A very common mistake is to just write x minus x plus 2, and that is wrong because we need to apply also this negative to 2, okay? So we have here 1 minus x minus 2. See how did I apply the minus there? Minus x minus 1 x over 2. And that is the solution of my first subproblem. Okay, so I go here, I put 4 over the solution of my first subproblem. Subproblem number 2 is that now we have a division of fraction. Okay, but I can do it here. 4 over 1 divided by minus x minus 1 x plus 2. Those are my two fractions that are being divided. Then 4 over 1 times x plus 2 x minus 1. And then in multiplication with fraction, we go numerator with numerator, denominator with denominator. Remember that we have here 2 terms, so that means that we need to distribute 4 with all the terms. So 1 times it stay the same. 4x plus 8 minus x minus 1. Let me see. Alex, yeah, you got it wrong there. Let me zoom out. I don't know how well you can see here. Maybe if can you follow the step here? Okay. All right. So that is the final answer here. Let me double check I did everything right. Yeah, it seems about right. Okay, so what if you want to earn 5 points? This is extra. This is not going to, if you don't do this, you're not going to lose 5 points. But if you want to earn 5 points for test number 3, please finish. Take a moment here, copy this, and I want to receive from you a PDF document in my email before 11:59 of today with the correct answer of this. Okay, and with all the steps, not only the correct answer, all the steps. In order to earn the 5 points, all the steps need to be there, and the answer needs to be correct. Okay, here there's no partial points. Is all or nothing. Okay, so I'm going to keep moving here. The review is already available on Blackboard. So yeah, 5 point on this, yeah. These are more exercise to practice. Let me present to you the review so you can follow the review with the class. Okay, so today we are working on composite functions. Okay, I will go there. Yeah. Okay, so in the review today we are covering page 2, 3, 4, 5. 2 to 5 is what we are covering today. Can you see it? Okay. Okay. Timothy, you got it? Okay, perfect. Okay. In the review, you will see the following. These are more exercises to practice. I'm not going to do this here in class, okay? But you will have the recording on the class. Also, if you want me to post this PowerPoint, let me know so I can do that. These are more exercises to practice here. The question is, the objective is to find the composition G of composition G and G composition of F with these three. We have we have 3 exercises where A, H, F, and G are given. Okay, so you will practice composition, but also I want you to state the domain, and you need to remember something about the domain. The domain. If we have operation that with restriction, for example, fraction, remember that fraction, the denominator, can't be equal to 0. Denominator can't be equal to 0, so that is how we identify the restriction of those particular functions, and then we can determine the domain. And here we have a radical with a power of 2, so the radicand, is what is inside that radical, need to be greater than or equal to 0. Okay, so there's, you have exercises to practice. Okay, and that is that part for composite functions. Let's move to talk about inverse functions. Yes, Timothy, for the 5 points, yeah. F composition, G composition of F composition of G, G composition of F, yes. Yeah, okay. So now we are going to talk about inverse functions. And before talking about inverse functions, we need to know what is a one-to-one function. And the definition of one-to-one function is the name itself, I think, explains itself, but the name explains itself very well. It's a one-to-one. So for different inputs, values of x produce different outputs. For example, let's see the 2 functions here. Okay, so for in the left side we have a not one-to-one function. Why? Because for different x values, so we have x equal 1, and you cannot see this well. We have x equal -1 and x equals +1. Both input values give us only one y value, which is y equals 1. So this is not a one-to-one function, because we cannot map just a specific x value with a specific y value. So this is not a one-to-one function. Okay? On the other hand, we have this function here, and this one, yes, it is a one-to-one function. Why? Because for each individual x value, we are going to map that x value with exactly one y value. All right. So here we have the horizontal line test. Okay. So why is a one-to-one function is important? Because what we are going to be focusing on depend on one-to-one function. We are now going to learn how to find the inverse functions. Okay, but to find an inverse function, we need to have a one-to-one function first. If f is 1-to-1, then f minus f. How we read this? F inverse, or the inverse of f. Okay, this is not f raised to the power of negative 1. Careful with this. This is not a power. This is the notation for the inverse function. Okay? If a function f is 1 to 1, so that means each x value corresponds to exactly one y value, then f inverse, or this notation, is his inverse function. Okay? If we have a 1-to-1 function, then we can get an inverse function from that one. Okay? What is important is, well, there are a few properties here, but an example of what an inverse function do. So these are usually the coordinates of f of x, and we have the coordinates. Okay? We know that we write the coordinates of the of each point in the plane x, y, right? Well, the inverse of f, what it does is to inverse the coordinates. So now the first entry in the coordinate is going to be the y value, and then the second entry in the coordinate is going to be the x value. So it flips. So the name itself explains the concept. We are talking about inverse functions. Okay? Interesting, this is something that we are going to use, is that if we create a composition of f with its inverse, is if the result or the equation always is going to give us back the input. Okay? If we create, if we create a composition of f with its inverse, it doesn't matter the order, always the equation is going to give us back the input. So the input here is x, right? Well, see at the equation is x. The input here is x, and the equation is x. Okay? Basically, they cancel each other, and what is left is going to be the input itself. Okay? This is the definition. Let's see examples so we can understand better this. Let's start with making sure that we are going to verify inverse function. Verify that the inverse of g of x is this equation that we have here. How are we going to verify? So we have two conditions to meet. We have g composition of its inverse of x. This need to give us back the input. Okay? But this is not the only one, the only requirement. We need both directions, because they need to be inverse to each other. Okay? So this is how we are going to verify that indeed we have inverse functions. So those are the conditions. So let's start with checking that these two are inverse to each other. So we are going to start with the left side condition that we have here. So that is the declaration g composition of its inverse equal to x. And then I'm going to just use the equations that we have here. So we have x to the power of 3, but now instead of x, I'm going to use the g inverse of x. And then I'm going to use the definition of the g inverse of x, which is 3x, which is cube root of x, all this to the power of 3, and these two get cancelled each other, and then we got x. So we are good with this part here, but we need to do both orders, both directions. So Now let's do this direction. G inverse composition of G. So we start with replacing X with G of X. Okay, then we got X cubed here, and these two get canceled as well, and we got X on both directions. Then just they are inverse to each other. Okay, there are some occasions where just one direction give us the input back. That is not necessary. If we just got one direction of this composition that give us back the input, then that means that the functions are not inverse to each other. Okay, to be inverse to each other, both directions need to give us back the input. Okay, again, how are we going to verify that these two are inverse to each other? We are going to test this composition, and if this composition gives us back the input and also the other one, the other direction, if we got that by these two composition, we got that we got the input again as an equation, then they are inverse to each other. Okay, and they are inverse to each other. These exercises are just to see what is the effect of creating composition of function when they are inverse to each other. Okay, they basically cancel each other, and we get back the input. Okay, same exercise. We need to verify they are inverse to each other. We create the two compositions, both directions, and if we get back the input, it means that they are inverse to each other. Okay, verify that they are inverse to each other. Now these ones are not necessarily inverse to each other. You need to practice, you need to work with the two conditions, and you need to see whichever exercise meets the two conditions, then you are it's guaranteed that they are inverse to each other, that the functions are inverse to each other. If we don't get the input back from the composition, it doesn't matter if we get just one direction the input back and the other one we don't get the input back. That means that they are not inverse to each other. To verify that they are inverse, to be inverse to each other, both directions of the compositions within the two functions need to give us back the input. Okay? All right. So I believe I'm going to post these slides on our classroom folder, so you have all those exercises there, so you can continue practicing. But also you have more exercises on the review, so you have plenty of exercise to do. I want now to focus on the how to find the inverse function. Okay, we have 3 steps. Okay, 3 steps to identify or to find the inverse function. Okay, given that the function is 1-to-1. So we are going to find the inverse function of f of x, which is equal to 2x plus 3. The first thing is that, is it f of x a 1-to-1 function? Yes, they are. Okay. The one that I'm going to give you, I'm going to be very specific. This is a 1-to-1 function. Now find the inverse function. Step number 1, replace f with y. Okay. So I have here y equals 2x plus 3 okay, so replace f with y and interchange variables y and x. So next step here, in step number 1, is that now we are going to interchange the place of x and the place of y. See what I did here? I just interchange x and y. Okay, just interchange x and y. That's all. Step number 2, then we are going to solve for y. Okay, so here from this one we are going to solve for y, and I don't have too much space, so I'm going to do it here. So we have this equation, and now we are in step number 2, solve for y. Okay, so that means that we need to isolate y. So then we go here, we subtract both sides first, and we got x minus 3 equals, we cancel this, to y, and then we divide both sides by 2, so we cancel here, and then we got y equals x minus 3 over 2. So y equals x minus 3 over 2. Okay. An extra step here that you want to do is to change now the y value or the y variable with f inverse of x. That is the proper notation of the inverse of f. Okay, f inverse of x. Okay, so that's the number 2. And then the last thing is what you want to do is to check that indeed we have found the inverse function. So let's do that. Let's do this here. So I have f to be 2x plus 3, and what I got is that its inverse is x minus 3 over 2. And to verify that indeed they are inverse to each other, what do we need to do is to test this composition to see if the composition of each other give off back the input value. In other words, is they cancel each other. Okay, we cancel here. Okay, so we have one direction. So we are good in one direction, but we cannot conclude that they are indeed inverse to each other because we need to test also the other direction. The other direction is f inverse composition of f. So we need to test also this one. Following the order operations, we cancel these two. We got 2x over 2, we cancel those two, and we got x as well. So yes, we have found the inverse function. Okay. So doing the test for the checking the invert function, we now are sure that indeed we have found the invert functions. Any question here? Okay. Let's do number 5. Okay, let's do number 5. We have 15 more minutes in class. So let's do number 5, and in those 15 minutes we can cover any question that you might have. Please post the answer for number 5. Remember the step. The step number 1 is replace f of x with y, and then interchange x and y. Step number 2 is solve for y, and then step number 3, verification. Verify that your answer is correct, or the inverse function that you have found is correct. Okay, we have 15 minutes. Please try do this. Post questions on the chat or just speak up. Okay, I'm going to be uploading these 2 presentations on Blackboard. Okay, let me know if you have questions. Okay, let me interrupt you for a moment. In Blackboard, if you go to our classroom and texture lectures, lecture materials, test 3 lecture materials is the folder at the bottom. I'm going to maybe is the folder at the bottom. You click here, and there you have lecture number 9. Today is lecture number 9. You have part 1, that is the presentation just with the composite function material. Part 2 is where we are doing one-to-one and inverse functions. Okay. Via email. Just submit an email with your work. Okay, Mohammed, yes, these are going to be uploaded. I'm going to stop the recording here because there's nothing more for the class. Now it's going to be just questions, but yes, you have everything here. You will have it available on YouTube.